Hello everybody, today we will be entering chapter 9. So chapter 9 is on quantization of light. So there are two subtopics in this chapter. It is a very short topic. So the first one is on theory part. So it is the Planck's quantum theory. Okay? So in this subtopic you should be able to state the theory itself and distinguish between this quantum theory and the other classical theory of energy, and lastly use the Einstein's equation for a photon energy, which is shown here. Okay, so let's look at the classical theory of black body radiation. So we know that black body is defined as an ideal system. So it is a system that absorbs all the radiation incident on it lah. Okay, so this electromagnetic radiation emitted by the black body is what we call the black body radiation lah. Okay, so from the black body experiment, we can then equate this into an equation which we call the distribution of energy lah. Okay, so it depends only on the temperature, and this temperature is not in degrees Celsius, it is however in Kelvin. Okay, so basically we know that if the temperature here increases, we can see that the energy is also increases lah. Okay, so basically what I'm saying is the energy is directly proportional to the temperature. Okay, so the spectrum of this electromagnetic radiation can be seen in this figure here. Okay, so from this curve, the Wien's, how do I pronounce it? Wien's whatever theory was accurate at short wavelengths. Okay, so for a very short wavelengths, it is actually accurate, but it deviates at longer wavelength lah. So as the wavelength goes longer, the it wasn't that accurate lah. Okay, so because of that, we are gonna use the Rayleigh-Jeans theory. Okay, so this Rayleigh-Jeans and Wien's theories failed to fit this experimental curve because of these two classical ideas lah. Okay, so first idea is the energy of the electromagnetic radiation does not depend on the frequency or the wavelength. Okay, and then the second one is the energy of the electromagnetic radiation is continuous. Continuously, it should be continuous. Okay, right, now let's look at the Planck's quantum theory. So in 1900, Max Planck, which is the one that discovered, ataupun the one that created this theory, proposed that his theory is fit with the experimental curve, which is the one shown here, the one with the solid line. Okay, and then according to okay, so the assumptions made by Planck, so the assumptions made by him in his theory are that the electromagnetic radiation emitted by the black body is separate ataupun discrete packets of energy lah. Okay, so there are packets of energy, and then each of this packet is known as the quantum of energy. Okay, so what he is saying that is the energy can actually be quantized lah. And then the second assumption made by him is the energy size depends on its frequency. Okay, so he said that the energy depends on the frequency lah. Okay, so according to these assumptions, we can then create an equation which is the one shown here. Okay, so H is the Planck's constant lah, which is the one shown here. And then since the speed of electromagnetic radiation in a vacuum is c equal to lambda f, we can then substitute into this equation here, so we get this formula shown here. All right, so from this equation above, the quantum of energy E here is inversely proportional to the wavelength lah. Okay, so this is convenient because we need to express many quantum energies in electron volts lah. So electron volt is a unit of energy. It can be defined as the kinetic energy gained by an electron which is being accelerated by a potential difference of 1 volt. Okay, so sometimes they would ask you in UPS lah, kadang-kadang dalam UPS ataupun in PSPM. I don't think so because your PSPM is only C3 and C4. Okay, so the unit conversion 1 electron volt is equal to 1.6 times 10 to the power of negative 19 joule. Okay, so if the question asks you to solve it in electron volt, you need to convert it into electron volt. If dia tidak minta, kamu just stay the unit in joules lah. Okay, okay. And then in 1905, Albert Einstein extended this Planck's idea that by proposing that electromagnetic radiation is also quantized. So it consists of particles like packets of bundles. Okay, basically Einstein agreed with Planck's. Okay, so for this electromagnetic radiation of n packets, where n is the real number ataupun number of energies di situlah, number of packets, it can be calculated by using this formula shown here. Okay, so now that is basically the theory part lah. And then the part where you need to calculate is using this formula here. Okay, okay. Now let's look at photon. So photon is defined as a particle with 0 mass, so it does not have any mass, and it consists of a quantum of electromagnetic radiation where the energy is concentrated. Okay, so these packets of energy or this bundle of energy is known as photon. Okay, so it can also be regarded as a unit of energy, which is equal to hf. Okay, so photons travel at the speed of light in a vacuum, and they are required to explain the photoelectric effect, which requires light to have a particle property. Okay, so we will be learning this, I think, in the next section. So this table here is telling us the differences between photon and electromagnetic wave. Okay, so electromagnetic wave depends only on the intensity of the wave. Okay, so we know that intensity of the wave is proportional to the square of its amplitude, whereas photon pula, energy is proportional to the frequency. Okay, so it depends on the frequency. Okay, that is the differences between photon and electromagnetic wave. Okay, and then for electromagnetic wave, the energy is continuous and spread out through the medium. So this is what we call the electromagnetic wave. Okay, and then photon pula, the energy is discrete. Okay, so that's what I mentioned just now. It is a bundle of energy. Okay, so this bundle of energy here, each of this is known as photon. Okay, okay. That is our first subtopic, and this is basically a lot more on theory, but you need to know how to calculate dia juga lah using this equation here. Right, so that is on subtopic number 1.